The price of transportation continues to increase globally, to the point that driving a car today has over time become very expensive. Beyond the price of the car itself, continued increases of retail gasoline price is hitting the wallet of all families. In this chart, the trend line associated with the price of retail fuel in the US clearly shows a long-term linear increase. And for most of what's worth, in most countries of the world, this line also increases linearly, usually faster than in the US. On the other hand, renewable energy technologies are maturing and are gaining popularity. The net result is that those technologies are increasingly affordable. Solar photovoltaic panels, for example, see the opposite pricing trend, as price per watt of hour energy produced by solar continuously falls as demand grows. And before I go in any further details on electric vehicles, I would like to debunk a myth which unfortunately continues to be widespread. No, electric vehicles do not produce more CO2 than internal combustion engines. I will be leveraging data from the International Energy Agencies from 2021. The assembly of a traditional combustion engine car and an electric vehicle generate approximately the same amount of CO2. The manufacturing and assembly of the large batteries required for an electric vehicle to function add, as you can see in green, some additional percentage of CO2. But this is neglectable compared to the CO2 required for production, distribution and burning of fossil fuel in the case of a combustion engine. Now, there is little that family car owners like us can do about the blue and the green CO2 emissions resulting from car manufacturing in these charts. We all know though that car manufacturers are all aggressively moving to a net zero factory production and longer term aiming at a zero greenhouse gas emissions. Though this will take more time and very likely newer battery technologies will have to be developed. On the other hand, by charging an electric car at home with renewable energy sources such as solar or wind as much as we can reduce greatly, if not eliminate entirely, the CO2 required to produce the electricity used to charge an electric car. With solar, we win twice. We reduced our ongoing cost greatly, and on top of that we save CO2. The average car driver will save thousands of dollars or pounds or euros annually and avoid the emissions of multiple tons of CO2 still annually. If you want to learn more about metrics in reporting, I recommend you review my detailed dedicated video to measuring your home CO2 reduction and savings, which can be found in this channel. So, if you had the opportunity to do so, why not invest in solar panels and an electric car? As electric cars are increasingly affordable, solar charging will help you save money and be more sustainable by reducing your CO2 emissions. Let's review how all this will work. At first glance, the setup is very simple. You install solar panels, which generate electricity for your house, and you connect an electric car charger to your house. So, technically speaking, job done, right? Well, not really. There are two dependencies that you must really be aware of to fully benefit from solar charging. First and foremost, you must realize that the batteries required to move a car weighing more than 1 ton, if not 2 tons, is much larger than all other batteries of your home combined. Charging the battery of an electric vehicle will require electricity, a lot of electricity. In the chart presented here, you can see the statistics of the electricity consumption of my home. Until 2:25 p.m., only my basic home appliances were on and consuming energy. This includes fridge, freezer, a few laptops, internet routers, and so on. At 2:25, I connected my car to the car charger and did what is often referred to as slow car charging. While fast car charging requires a specialized system such as superchargers not usually available at home. Unless if you're an expert, plan for this type of demand with your electrician and solar energy specialist. Solar electricity production follows the same bell curve pattern on a daily basis. Shortly after sunrise, electricity production will start small and grow until the sun reaches its peak, and then will slowly decrease towards zero before sunset. The next day, the same cycle will happen again. If we look at longer-term statistics, we observe the same bell curve every single day of the year. Taking the same example of my car, charging is of 2:25 p.m. If I start charging my car at that time at 16 amps, which is where I live, approximately 3,500 watts, the car charging solution must be able to adjust the car charging level up or down with solar electricity generated. At the end of the day, the system must be able to automatically pause the car charging until the next day, when solar electricity to the production will resume. To solve this problem, we can leverage energy routing, and basic solutions are widely available out of the box with most car charger manufacturers. Energy routing compares the solar electricity production with the needs of your home. In this example, at a given time of the day, 5 kilowatts are being produced, whilst the house only needs 1000 watts. At that specific time, this means that we have 4000 watts available to redirect, for example, to charge an electric car. The smart meter installed between your solar production system and your house will instruct the car charger to adjust up or down the car charging, or simply pause it because there's no green energy available. This is called energy routing. Monitoring is continuous, meaning that if we have temporary clouds in the sky, reducing our electricity production temporarily, our house consumption will remain intact, whilst the car charge will be reduced to the solar energy currently available. Many car charger vendors offer solar charging solution as supported kits. Just ask your solar solution local vendors and they will help you with it. Unfortunately, basic energy routing based on 1 meter has serious limitations. Most car charging solution vendors do not support charging multiple cars, and almost none have solutions that support both car charging and home batteries management. Very few support a solution if you're entirely disconnected from the grid, which is, by the way, my case. More advanced use cases would, for example, include charging one car more than the other if the first one has to drive more kilometers. Solving this requires a new approach to home grid management. We will review the implementation of a smart home grid solution in a dedicated video and review smart car charging in another video entirely dedicated to car charging management. As always, if you like this video, please hit the like button, and if you want to learn more about the sustainable journey, consider subscribing to this channel. I would like to hear from you and how you benefited from charging your electric vehicle from sustainable sources such as solar or wind, and also what challenges you faced. Thank you, and I will see you in the next video.